Good morning, students. Welcome back to our online mathematics class. So as we have started with miscellaneous and I have solved previous questions, so now we're starting with question number 4. If x minus iy is equal to square root of a minus ib upon c minus id, prove. You have to prove this. X square plus y square whole square is equal to a square plus b square upon c square plus d square. Now remember, students, whenever it is given to prove, so this means something else will be given, from that you have to prove. So what is given to us? This is given to us. X minus iy is equal to this. Then we have to show that or prove that x square plus y square whole square is equal to this. Okay, so starting with what is given to us. Okay, so starting with what is given to us. So x minus iy is given to us a minus ib upon c minus id. If I multiply and divide by the conjugate, so conjugate I have explained in detail in previous video, students. Now I'm not repeating, I'm doing directly. So c plus id upon c plus id, okay, square root. Follow till here, students. Now multiply this a minus ib into c plus id, so this will give me ac plus aid minus plus minus minus ibc minus plus minus I square, right, minus I square, so plus 1, so plus bd. Okay, students, ibc here I am doing in rough. ib into id is equal to I square bd, I square minus bd, and here it is all minus plus minus, so it will become plus, so plus bd upon c minus id into c plus id, students. A plus a minus b into a plus b is a square, right, minus b square. So I square is equal to minus 1, so minus 1, and this will become plus b square. Followed a plus b into a minus b is a square, so c square, right, minus b square minus I square b square. I square minus 1, so minus minus will become plus, correct. So we're getting this. Alright, I can rewrite this as, okay, taking the real parts and imaginary part together, students. So I will get AC plus BD, right, plus I, AD, right, AD plus IED minus BC. Are you following, students? I am taking real parts and imaginary parts. Okay, real parts AC plus BD, imaginary part will be AD minus BC, AD minus BC, yes, upon C square plus D square. I hope no problem till here, students. Just multiply and divide by conjugate and simple multiplication. So I am getting now x minus iy is equal to AC plus BD plus I AD minus BC upon c square plus d square, c square plus d square whole square root. Now see, students, if I have to remove this square root, what should I do? I should take square on both sides. So taking square on both sides, okay, I'm writing taking square on both sides. Okay, so if I take square on both sides, what will I get? X minus 5 whole square, x minus iy whole square is equal to square of this will be vanished, student. Okay, so I'm writing directly now. Okay, you are in 11th class, you should know. Okay, if I take square here, so the square root will vanish, so I will be left with AC plus BD plus I AD minus BC upon C square plus D square. Now I can write real part and imaginary part separately, so this is equal to AC plus BD upon C square plus D square plus I AD minus BC upon C square plus D square. Understand this step, students? Since this whole, okay, a square AC plus BD plus IAD minus BC is divided by C square plus D square, so I am taking real part and imaginary part. So this is your real part, AC plus BD upon C square plus D square plus IAD minus BC upon C square plus D square. Now if I open this bracket on the left side, this, if I open this, so A minus B whole square, so A square, right, plus b square a square plus b square minus twice ab, right? So see, x minus iy whole square, a minus b whole square is a square plus b square minus twice ab. So x square minus y square minus 2ixy. Are you following, students? I square is equal to minus 1. So minus y square is equal to ac plus bd upon c square plus d square plus I ad minus bc upon c square plus d square. I hope you have followed till here, students. Now I can compare real part and imaginary part. So x square minus y square is your real z. Okay, let me change things so it will be easy for you to differentiate. So this is your real part. Okay, this is your real z. Okay, and this is your imaginary because I is here. Okay, and compare this. So this is your real z and this is your imaginary z. Followed, students? Have you followed the difference? So x square minus y square is equal to this, and 2xy, I and I cancelled, so minus 2xy is equal to ad minus bc upon c square plus d square. Okay, are you following, students? So I will write this. Okay, I can just write all this. Okay, and then I'll continue solving. Alright, students, so now comparing the real part and imaginary part, we have got x square minus y square is equal to ac plus bd upon c square plus d square, and minus 2xy is equal to ad minus bc upon c square plus d square. Now see, we have to prove x square plus y square whole square, but we are getting x square minus y square. So if you remember this relation you studied in your previous classes, I can write x square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. Remember this relation, this is very important. If you don't know this, you cannot solve the question. Okay, remember this. So x square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. Okay, let me change things so it will be easy for you to differentiate, student. Alright, so I'm taking this, right? We have to prove now x square plus y square is equal to this. This means x square minus y square, this value I can substitute whole square. If I take square of this, minus 2xy square of this will be 4x square y square is equal to this. So I will be getting this, right? So I will substitute the values of x square minus y square. So x square minus y square is this. You can clearly see, students, equation 1. And 4x square y square, if I take square of this, I will get this equation 2, right? So I'm solving now. AC plus BD upon C square plus D square, right, whole square plus, if I take square of this, right, so this will be 4x square, right, is equal to AD minus BC upon C square plus D square whole square. Are you following, students? If I take square of this, so this will be minus 2 whole square will give me 4x square y square is equal to square of this term, right, square of this term. Followed? So that is why I'm writing here directly. Okay, so 4x square y square. Now I can open this and solve. Okay, so this will give me AC is, so I'm solving directly, a plus b whole square a square plus b square plus twice a b c d upon c square plus d square whole square. Okay, I have solved this, students. Okay, now solve this plus AD minus BC. AD minus BC is A minus B whole square. So A minus B whole square will give me A square, right, plus B square minus twice AB, so twice AB CD upon C square plus D square whole square. Now you see, students, denominator is same, so I can directly add this. So this is equal to A square C square plus B square D square plus twice A B C D plus A square D square plus B square C square minus 2ABCD upon C square plus D square whole square. Now see, plus 2ABCD and minus 2ABC cancelled. Okay, so what are we left with? A square C square. So I can write like this. A square is common from here, so I can write A square C square plus d square. C from where, students? A square. Okay, let me change the ink. It will be easy for you to differentiate. Okay, students, try to follow a square and c square. So I have taken a common, c square plus d square. Similarly, plus b square if I take common, so d square plus c square. See this, d square and b square c square. I have taken b common, so I will be left with this now upon c square plus d square whole square. So I am writing this equation here. Okay, this is equal to, students, a square, right, c square plus d square plus b square c square plus d square. I can rewrite this d square plus c square as c square plus d square, does not make any difference, upon c square plus d square whole square. Now if I take c square plus d square common from numerator and denominator, so c square plus d square common, right, from numerator and denominator, so what is left inside? A square plus b square, right? Now if I split the denominator c square plus d square, twice means 2 times, right? So I can cancel this now. Okay, I can cancel this, students, clearly, right? I can cancel this and this cancel. So what is left now is equal to a square plus b square upon c square plus d square. Okay, this is equal to what? X square plus y square whole square. This is what we have started. Okay, so implies, hence proof, right? Hence proof x square plus y square whole square is equal to a square plus b square upon c square plus d square. Okay, students, so good question. This is what we have to do. We have to keep this identity in mind, students. Okay, this identity is very important, because using this identity using this only we can solve, otherwise you won't be able to solve this question. Okay, are you following, student? Now this is simply calculation work. Okay, see here, I'll repeat from the beginning. Till here, have you followed? We calculated the values of real part and imaginary part, right? So what we have to prove? We have to prove that x square plus y square whole square is equal to this. Now if you see, we are not getting anywhere x square plus y square, we are getting x square minus y square. So this we have to think from ourselves, what relation is there between x square plus y square and x square minus y square. We studied this identity in previous classes. So x square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. Now we have to simply substitute the values and solve. Whose value? X square minus y square. See here, x square minus y square value is AC plus BD upon C square plus D square. So AC plus BD upon C square plus D square whole square plus 4x square y square. 4x square y square we are getting from here. See, students, minus 2xy whole square will give me minus 2 whole square, 4x square y square is equal to AD minus BC whole square upon C square plus D square. That is what I have done. Okay, and substituted here square, and now solve this. Okay, so square of numerator, square of denominator. So AC plus BD whole square will give me A square plus B square plus twice AB upon C square plus D square. Using this identity I have solved this. So A plus B whole square, solve this, will get A square C square plus B square D square plus twice ABCD. Now it is very elementary, students. A minus B whole square is A square plus B square minus 2AB, right? So substituted the identity. Now C square plus D square whole square and C square plus D square whole square. Okay, this, are you following, students? So in this way we will substitute the values. ABCD, twice ABCD minus 2ABCD cancelled. Okay, so what is left? A square C square and A square D square taken common, C square plus D square, and same thing here, B square taken here, D square plus C square. Okay, from here then we have this. Okay, from here I started from here, A square C square plus D square plus B square C square plus D square. Now taking C square plus D square common. Okay, after here then I have to start from here. Okay, started from here, students. Okay, and then taken C square plus D square common, cancel. So what are we getting? A square plus B square upon C square plus D square. That is what we have taken equal, and that is what we have to prove. Okay, so in this way we will solve. So good question. I have explained in detail, students. See previous slide. Okay, and this slide, in this way we will complete the question. I hope you have followed. Study well and do good, students. Any problem you can always get back to me.